Hi students, let us continue with the topic quicksort. In the previous video I explained about the first phase of the quicksort, that is a partition phase. Actually the quicksort algorithm, I said it is divided into two phases. So one is the partition phase and the next one is the sort phase. Okay, so in the partition phase we divide the work, whatever the array is there, that work into two halves. There we will select the pivot element. So the pivot element is any element that is present in an array. So that pivot element has to place in certain position, so that the pivot element, left side element should be less than or equal to pivot and the right side element should be greater than or equal to pivot. So up to that the partition will be over. So after arranging the pivot element, we have to apply the algorithm, that is a sort algorithm. So let us see the quicksort algorithm. So in the previous video I explained about that partition phase and the sort phase. So the partition phase is just to find out the position for the pivot. So just place the pivot element in the center. Left side should be lesser elements than pivot and the right side should be the greater than the pivot element. Now coming to the sort phase. So here we will apply the same algorithm to each halves. So let us see that. The algorithm for this is quicksort. A is an array, start element and the end element. So if start is less than end, suppose if the start is less than end, then we have to do p index is partition A comma start comma end. So now quicksort A comma start comma p index -1, again quicksort A comma p index +1 comma end, close the if condition and the quicksort. So this is the algorithm for the sorting the this is sorting phase, the quicksort algorithm. So in the previous video I explained the partition algorithm and how the unsorted array has to be taken, and in that we just partition the array by selecting the pivot element and placing the pivot element in the correct position. Now we'll take that partition array, that is what we have previously we have discussed. So that is the example. Let me write that example. So whatever the partitioned array is that we have taken, so actually the normal array which is unsorted is this one is the unsorted array which I had explained in the previous example. So this is an unsorted array 0 1 2 3 4 5 6 7. Okay, so now here this is a pivot element, so better select the last element is a pivot element. Now that pivot element has to be placed in the middle. So just like the array after partition is 2 1 3 4 8 5 7 6. So this is the array which we get as the elements which we get after partition. So now we have to sort this array in a sorted manner by using the quicksort algorithm. So by using this algorithm we have to arrange the elements in an ascending order. Okay, this is the sort phase. So already in the partition phase, with the help of the partition phase, we just find out this array. Now we have to sort this array by using the pivot element. So here the pivot element is the 4 is the pivot element. Okay, so now divide the, this is 0 1 2 3 4 5 6 7. So first what we have to do, if start is less than end, okay, start is less than end, so we have to make this, first we just partition it So here did you observe the elements that are present left side the pivot element or less than pivot value, and the right side the pivot element or greater than the pivot value. So just divide it. By using the divide and conquer method, you have to divide it. 2, 1, 3, and this is 8, 5, 7, 6. Okay. So now this becomes the pivot element. So this is in this array, the sub array. So this is a pivot element. So now we have to check, is the left hand sides or less than or equal to pivot value or not, and the right hand side should be greater than. But here this array 3 is the pivot value, so we have to check the left hand side. So 2, 1 both are the less than pivot value. So now again divide 2, 1. So now 1 becomes the partition pivot value. Okay. So the less than should be the pivot value left hand side should be less than or equal to pivot value. But here it is greater than. So just you have to swap this and make it as 1, 2. Okay. So here 0, 1, 2, 0, 1, 0, 1. Don't forget to write the indices here. So now the array is sorted. So here this, suppose if you take this 1 is the pivot value here. Okay, if you again split this, then finally you will get only 2. So actually we have to recursively done the this is the recursive statement. The quick sort has to be done. The sorting should be done recursively until you reach one element. So whenever you find the one element, you have to stop the recursion. Stop recursion. Okay. So this is the left hand side. So here, what is the sorted array I got now? So the 0 is in the 0 place 1. So 1 index you are having 2, and the 2 index you are having 3, and already the 4 is there. So this left hand side's elements are sorted. 0, 1, 2, 3. Okay. So until you reach the one element, you have to sort, you have to divide the array, you have to split the array into 2 halves, and you have to select the pivot element, and you have to swap the elements. Okay. So here the 0, this is 0, and here 2, this is 1, and this is, and this is. So this array is sorted. Now let us see the left hand side. So the 6 is the pivot value here, because the left hand's last bit should be the pivot value. Now divide this. Okay. So whenever the pivot value is there, you have to be arranged like that. The left hand should be greater than the less than the pivot value, and the right hand should be greater than the pivot value. So say 5, 6, 8, 7. So like that. So these values are 4, 5, 6, 7. These are the indices 4, 5, 6, 7. So now the 6 is the pivot value here. Now split this. Here 5 and here 8, 7. So we reached one element. So you have to stop the recursion here. But here 2 elements are there. Here the 7 is the pivot value. You have to swap this. 7, 8. Okay. So whenever the 7 is the pivot value, you have to divide it, and this is 8. So you have to stop the recursion because you reached the first element. So the indices for this is a 4, and this is 6, 7, 6, 7, 7. So now you get the final array. So the 4 is having, the 4 indices is having the 5th element, and the 5 is 6, and the 6 is 7, and the 7 is 8th element. So now the array is sorted. 1, 2, 3, 4, 5, 6, 7, 8. Merge this array. 1, 2, 3, 4, 5, 6, 7, 8. Means combining the problem. So this is by using the divide and conquer method, we are just dividing the problem and solve the sub problems. Again you are combining, you are conquering the problem. Okay, you will get the original solution. So whatever the array we are given, that array is sorted by using the quicksort algorithm. So the quicksort algorithm can be done by using two phases. One is the partition phase and next is the sort phase. In the partition phase, we will find the pivot value and we will place the pivot value in the correct position. So this is the partitioned array. So after partition, we have to divide the array into subparts and we have to be swapped by using the pivot value. Okay. So this is about the quicksort algorithm. Thank you.